In Google CTF 2023, I solved Symatrix challenge from this category. The description says, the CIA has been tracking a group of hackers who communicate using PNG files embedded with a custom signography algorithm. An insider spy was able to obtain the encoder, but it is not the original code. You have been tasked with reversing the encoder file and creating a decoder as soon as possible in order to read the most recent PNG file they have sent. In the attachment, we are provided with two files, a 6000 plus line C code encoder.c and an encoded PNG file. After skimming through the file,
One eternity later,
I found some Python snippets in the multi-line comments. I extracted and arranged these comments according to this number.
Using the script.
A link to this script can be found in the description. If you want more explanation on this, please leave a comment. Now if we see the code that has been extracted, we can see there are repeated lines of code. By removing them manually, we end up with a short Python snippet. These are just functions to which we come back later. If you see, we read the flag file as binary, convert the data into hex, open the original image, note down its dimensions, creating a variable with twice the xlen of original image. Creating a new RGB image with image.new function, loading both images data into variables, converting the aforementioned hex data into binary string. Now coming to the two for loops, looping for every pixel in the original image, copying the original image's pixel into the same position in the new image. If we ignore the if condition for a moment, we can see in the else block, we are keeping the pixel as it is. So we can remove all the pixels that are same in the original and modified portion of the new image. Now, if we see the if condition that we previously ignored, it contains three conditions. The first one is just to check if the message to be encoded is left or not. The second is just randomly placing pixels. The third, you will understand when we see the following code. As we know, the size of a new image is twice the original, and we also know that the first half of new image is same as original. We can see the second half is being filled from the right end towards the center. Using functions that we ignored previously, which are embed and pixel bit. In the pixel bit function, we are just creating a tuple 0, 1, b, where b is the bit from the flag, which can be a 1 or a 0. And in the embed function, we can see we are taking two tuples, adding their corresponding values. So now we understand why we are checking it is a full pixel. As we can see, we are modifying the pixel at first position and second position with respect to 0 based indexing by adding at most 1 to it. So these are required to be less than 255 to make a valid image. So as we used 0th bit of the binary string, we are removing it from the string and decrementing the remaining bits variable. Now that we understand how the encoding is done, let's write a decoder. Most of the setup code is same, where we just inverse the operations done, and in the loop we just check if the pixel from original half of the new image and the modified half of the image are equal, just discard, or else take the difference of the value at second position. It will be either 0 or 1. Group 8 bits and convert the 8 bit into a string and then to integer and then to a character. Voila, we got the flag. Please share if you have any feedback or if you have any doubts in the comment section. Thank you.